Welcome to Module 3 of the DevOps Foundation course. We're going to talk about key DevOps practices. Starting with a case story, Topo Paul is a pretty well-known speaker in the DevOps world. He's been leading the DevOps transformations at the bank Capital One. It's been a pretty remarkable journey. He says tools are a big part of today's Agile and DevOps methodologies. A typical project deals with Agile project management tools, source control, continuous integration tools, testing tools, static code analysis, security scanning, deployment and monitoring tools, to name a few. Large enterprises and complex systems sometimes use multiple CI testing and scanning tools. Each of these has a nice dashboards to present key information stored in it, but what is lacking is a single comprehensive end-to-end view of the state of delivery pipeline in near real time. At Capital One, we believe that while tools, automation, and collaboration are very important, a continuous feedback loop is critical to the DevOps success. So that's encapsulating at least some of the concepts of the principles of the two principles: flow, the first way, and feedback the second way. Capital One is quite famous for contributing a really good DevOps dashboard. It's called Hygia. It's open sourced, and Topo was a lead on that. So anyway, what did they accomplish? And by the way, it's an ongoing story. They're continuously improving their DevOps environment, but they were able to get to hundreds of code commits per day from where they were, which was a lot less than that. Having integration from once a month to every 15 minutes, so quite a remarkable change. Quality assurance from once per month to 4 times a day. So they've automated a lot of their testing. The deployment from manual to completely automated, so hands-off deployment. And production releases from monthly or quarterly to once per sprint. So they're basically making a release every time they go through a sprint now. They've automated their CI/CD to the level they have confidence to do that. The point is that everything is driven by data, technology, automation, data science. So they're very much data driven now. So this is a pretty good success story. So let's talk about some of the core practices associated with DevOps. So continuous testing, integration, delivery, and deployment. Starting with continuous testing. And by the way, just like DevOps, there's no standard definition for these things. But this is a statement that I like. Continuous testing is a quality assessment strategy in which most tests are automated and integrated as a core and essential part of DevOps. Continuous testing is much more than simply automating tests. I've noted that quite a few definitions out there just say continuous testing is the same as automating tests, but it's actually a lot more than that. It's certainly more than just automating execution of tests anyway, because there's a lot more to testing than just automating the execution of tests. You have to have test creation that keeps up with the pace of change, and test selection, test environment setups, and test execution, certainly, and then test reporting, results, and analysis. So there's a lot to testing, and continuous testing really encompasses all those things. If you were to attend the Continuous Testing Foundation course, you'd hear a lot more about that. So another factoid from the State of the Quality Report 2024 says nearly 75% of participants in that survey are using test automation, at least to some extent, marking a significant rise from 63% in the previous year, and indicating a continuous trend towards increasing automated testing. So automated testing has sort of become table stakes for most organizations. You can't really get very far without it. It's often the bottleneck in a lot of value streams if you're not automating testing. The bottom line here is there are substantial advantages of test automation beyond just return on investment, because certainly automated testing generally has a high return on investment because you can run all these tests without human intervention. It saves a lot of labor. So with 51% noting enhanced quality. So it's not just that you save labor, but you also improve quality while you're at it. 49% emphasize more frequent and thorough testing, so you get more test coverage typically. 46% observe an increased test coverage. 42% credit it with reducing software delivery time. So my own experience is testing is often one of the first things that you're going to tackle in a transformation once you have your basic, structure in place for CI/CD. All right, let's talk about CI. There's an interesting book here that's a little dated now, but it's still very relevant, by Paul Duvall, Stephen Mattis, and Andrew Glover. It's still kind of the I think the standard for CI. It talks about improving software quality and reducing risks. So that's a book worth having. It's the Edison Wesley publisher. So again, CI is not a hard definition, but this definition works. Continuous integration is a software development practice in which the members of teams merge their changes into a code base together with their colleagues' changes at least daily. Each of these integrations is verified by automated build and tests to detect integration errors as quickly as possible. So it's certainly a practice affiliated, closely associated with the front end of the CI/CD pipeline, where developers check in their code basically, and the best practices at least daily. More frequently is also good. Excuse me. So CI allows for early detection, quick remediation of errors from code changes before they go into production. It requires source and artifact version control repositories and continuous integration servers to collect, build, and test committed code altogether. Each check-in from the developers is validated by input checks, source code quality and security scans, an automated build, and typically unit and integration tests, at least the functional level integration tests. Some call it smoke tests, at least a basic set of functional tests. And generally, if you're using containers, this is where you do generate containers as well. So you're testing against a container from that point forward. It generally concludes with a version labeled release candidate artifacts in an artifact repository. So that's usually the demarcation point between CI and CD, is when CI has produced a qualified release candidate that's ready for further testing through the CD process later. This is the result of a survey from the DevOps Institute. Just they surveyed different, DevOps experts and companies, saying, what are the skills they feel are essential for CI/CD and DevOps. Continuous integration is certainly very high up there. I'm surprised it's only 56%. Actually, I don't see how you do DevOps without CI. So at least build and test automatically. Continuous deployment also is way up there, which I'm actually surprised, because continuous deployment you're going to see is harder than continuous delivery. And generally speaking, you want to do continuous delivery prior to deployment, because deployment is where you automatically deploy to your production base. That's often requiring a manual decision in many organizations until they have continuous delivery, very well refined. And continuous testing, again, I don't see how you get very far without that. And DevSecOps, continuous security. So all of these are roughly at the same level, I guess, statistically speaking. And I would agree with that pretty much. But if I was to order it, I'd say CI is the minimum, then probably testing, automation, and then delivery, and then deployment, and then security. If roughly in order, if you were implementing a strategy, only because you need to have CI to build on before you can do CD, and you need delivery before you can do deployment, and all of these things need testing, and security is something that you better be doing. So all of that needs to be integrated pretty much together.